So in this lesson, we're going to talk about the second type of conic, the ellipse. And if you remember, conics are formed by cones being intersected by planes, and the impression that is left on the plane would be the two-dimensional conic that we're discussing here. So the definition starts out similar as in set of points in a plane. Now for the ellipse, it's a set of points in a plane such that the sum of distances between two fixed points. Now there's two of them. Plural is considered the foci is constant. So set of points in a plane such that the sum of distances between two fixed points is constant. So the equation for the ellipse that we're going to deal with is the x minus h squared over a squared plus y minus k squared over b squared equals 1. This is where the center of the ellipse is the point HK, and similar to the parabola, we're going to have a secondary formula that we're going to need to come back and fill in. Now there are two basic types of ellipses that we'll study in this section. One of them will look more elongated horizontally, and one will look more elongated vertically. The foci that we're mentioning in the definition will occur kind of to the inside, if you will, of the ellipse on both of those. And then we'll also identify the difference between them by using their major and minor axes. So for the first one, the major axis we would call the x-axis. The axis on which the foci lie would be the x in this case, so major axis. The minor axis in this case would be y. Similarly here, we would have a major axis of y, because again the foci lie on a vertical or a y-axis, and the minor axis in this case would be x. So major versus minor axes will be really important here in just a minute. So I'm going to go ahead and get a picture drawn of the ellipse in general, and we'll talk a little more about the definition and how it relates to A, B, and everything else in between. All right, so the ellipse that we're going to start with our picture, you can see that the center would be 0, 0, and then I've noted that A is bigger than B, so that's actually going to imply we're going to have a major axis of x. So if I go ahead and I sketch the ellipse up here, something like that, with the center at 0, 0, and a major axis of x. The foci here would be on the x-axis, about right there. And now I'm going to go ahead and label some points, some pretty important points as well. I'll go ahead and I'll start with this guy and this guy. So I'll label this first point here A, comma, 0. And this one then would be negative A, comma, 0. Now what that means by labeling the point, what we did is that A represents the distance from the center to the outside of the ellipse along the major axis. So A is the distance from the center to the outside of the ellipse along the major axis. Make sure you know that. Then I'll label this point up here and this point down here. This one I'll call 0B, and this one I'll call 0, negative B. And in a similar way, B now represents the distance from the center to the outside of the ellipse along the minor axis. So when you think of A's and B's, A is always associated with the major axis, B is always associated with the minor axis. These foci that I put in here, I'll label C0 and negative C0. So then C would be the distance from the center to the foci. So A, think of major axis, B, think of minor axis, C, think of the foci. So the definition of the ellipse says that the sum of distances between two fixed points is constant. So for example, if I start at this foci over here, this focus over here, and I come down to some arbitrary point, x, y, and then I come back up to this one, then D1 plus D2 should be constant. So by the definition, D1 plus D2 equals a constant. Now, that constant is actually able to be picked out pretty easily by selecting a more specific point xy. If I come from this focus up to 0b and down, I'm essentially doing the same thing. So my two yellow lines added together should equal my two green lines. And by picking the yellow lines, you can now see there sits a triangle right here. So this triangle right here is going to be a really important one. So much so that we know that would be a C value, this would be a B value, and it's a little bit hard to see, but if I take this hypotenuse right here, which has got to be the longest side of the triangle, and I pull it down, it's actually going to be the same length as it is from the center over here to A. So this hypotenuse would be A. So in terms of adding this guy up with this guy now, our constant would be 2A. So D1 plus D2 equals a constant of 2A. Now, that triangle, again, is going to be really helpful for now our secondary formula. If you look at that triangle, it's a right triangle. So by the Pythagorean theorem, we can see that A squared would equal B squared plus C squared. So go back in your notes under the equation and fill that in as the secondary formula. And that's going to help us connect a lot of this information here in a few minutes. All right, so in our first example, we'll find the equation of the ellipse with foci plus or minus 3, 0, and y-intercepts 0 plus or minus 4. And so I'm going to go ahead and just start with the equation of the ellipse so that we can better understand what it is we're looking for. So if this is what I need to fill in and essentially have as a final answer, this is going to tell me that I need two things. I'll need the center, HK, and I'll also need A and B. So that's going to be kind of two things in one, but one comes with the other. So we'll need the center and we'll need A and B. So what I'll do next is I'll go ahead and actually plot the 4 points that's given to us. And I'm believing that if I get these 4 points on here, I'll be able to figure some things out. So the foci at plus or minus 3, 0, so maybe there and there. And then the y-intercepts of plus or 0 plus or minus 4 would be maybe there and there. So from simply doing that, we can now see that the major axis is going to be x and the minor axis would be y. I know that because the foci have to lie on the major axis. So my ellipse might look something like this, which is an absolutely awful ellipse, but you get the idea. You can see now it's pretty clear the major would be x and the minor would be y. So from there we can also see that the center would have to be 0, 0. The foci are going to be equidistant from the center, both units of 3, so 0, 0 there. And now, having sketched this in, we're actually able to also identify these points. Well, y is the minor axis. So the minor axis is always associated with the b value. So our b would actually equal 4. Now, once we have b, and we also have c for that matter, don't we? The c, coming from the picture, c would equal 3. We can now use our secondary formula, a squared equals b squared plus c squared, to find the last piece that we're missing, which would be a. So a squared equals 16 plus 9, a squared equals 25, or a equals 5. So to put all this together, I'm going to have an x squared, a y squared, and a 1. Underneath the x is the major axis, so underneath the x, we're going to have the a squared, which is 25. Underneath the y squared, which is the minor axis, we're going to have a 16. And we've got now our equation of the ellipse. So now in this example, we'll actually go from the very beginning here and put the entire graph together for the ellipse. The things that we'll be looking for on the right-hand side of the screen, we need the center, the major, the minor axes, the foci, and then 4 points as well that I'll show you here in just a second. Now, to get this into standard form, we're going to need to start by completing the square. And you'll always complete the square with respect to a variable, so in this case it's going to be done twice. I'll factor out the 4 to make sure my leading coefficient is a 1. The y squared is okay, so I'll just put the blank in there, move the 21 to the other side, and remember these blanks always come in pairs, so we want to make sure to add 2 blanks to the right. So then in our first blank, half of 4 is 2, and we square it. Now to be clear, we actually just put a 4 times a 4, which is a 16, on the left, so we need to put a 16 on the right. Now for the second blank, half of 6 is 3, and we square it. If I put a 9 on the left, I need to put a 9 on the right. So this actually now factors into x plus 2 squared plus a y minus 3 squared equals a 4. And if I now divide everything by 4, I'm going to have my equation in standard form. I want to make sure I have that 1 on the right. So there's our equation in standard form. From here, we can identify a lot of the information. We can see that to start, our center is going to be -2, 3. We can see that the major axis is actually going to be y. Now I can see that because for the ellipse, whatever number is bigger on the bottom. So in our case, the 4 is bigger on the bottom. That means we're going to be counting out along the y-axis from the center more units than we are left and right. So if we count more units up and down than we do left and right, you can see that the ellipse would be elongated vertically, meaning our major axis would be y. So our major axis is y, our minor axis is x. I'll go ahead and I'll plot what I know so far. Center at -2, 3. So here's -1, -2. There's our center. And if we call the major axis y, then this guy right here has to be our a squared, and this has to be our b squared. So from the center, I'm going to count up and down 2 units. So 2 units down and 2 units up. And from the center, I'm going to count right and left 1 unit, because that's my b value. And when I connect those 4 points, that's going to give me the ellipse. The 4 points that I have marked there, those are the 4 points I'm talking about over here. So we'd go ahead and fill those in. The first point would be -1, 3. Then we'd also have a -2, 1. We'd have a -2, 5. And we'd have a -3, 3 as well. Now for the foci, this is where our secondary formula will come into play again. We know for the ellipse that a squared equals b squared plus c squared. So 4 equals 1 plus c squared equals 3, or c equals the square root of 3. Remember, we define a, b, and c to all be distances, so we really only care about the positive values. You also want to pay attention, c is the square root of 3, which is approximately 1 point something. So from the center, if I count up and down approximately 1 point something, notice how it still keeps me inside the ellipse. That's actually a pretty important point and concept for something that's coming down the road. So we've got our foci. We'll go ahead and identify the foci as having an x-coordinate of -1, and the y-coordinate would be 3 plus or minus the square root of 3. So we would start here at 3, and we'd go up square root of 3, and we'd go down square root of 3. for the y coordinates. So we have the equation of our ellipse, we have a graph, we have center, major, minor, foci, and 4 points identified, and I think that's all we need for this one.